The introduction of our group assignment is transistor biasing is pivotal in electronic circuits, establishing the cue point for linear signal amplification. Fixed collector feedback, emitter, and voltage divider biasing circuit are employed to achieve stability and optimal performance. Proper biasing ensures the transistor operate efficiently, striking a balance between linearity, stability, and the ability to handle a wide range of signal amplitude in various applications.
Assalamualaikum. My name is Muhammad Yusuf bin Sukri and my metric number is 222045. We can get a IC saturation from the datasheet for transistor 2N3414. We can use a IC saturation 50 milliampere. For design stage part 1, we put a 3 voltmeter in parallel to measure volt, and we put a 3 DC emitter in series to measure ampere, to measure a current. This is our design stage for part 1. For simulation result using software, for IC, for simulation we got a 30/7 milliampere, and for calculation we got 25 milliampere. For IB, with simulation value we got 0.10 milliampere, and for calculation value we got 0.11 milliampere. For IE, we got 30.8 milliampere, and for calculation value we got 25 milliampere. VC, for simulation we got 9.22 volt, and for calculation we got 7.5 volt. For VB simulation value we got 11.5 volt, and for calculation value we got 12.01 volt. For VE simulation value we got 9.22 volt, and calculation value we got 2.25 volt. RC, for simulation we have a 300 ohm, and for calculation also get a 300 ohm. RB, for simulation we got a 109.55 kilo ohm. Also for calculation we got 109.55 kilo ohm. For RE we got 90 ohm for simulation and 19 ohm for calculation value.
Assalamualaikum. My name is Muhammad Ahmad bin Sofi. My metric number is DAE21303. We use for voltmeter to measure the volt for each resistor, and for emitter to measure the four resistor and one emitter to measure the transistor. This is a table result for circuit part 2. The simulation value for IC 23.3 milliampere and calculation value for IC 25 milliampere, and simulation value for IE 23.4 milliampere, and calculation value for IE 25 milliampere. Simulation value for R1 for IR1 1.49 milliampere, and calculation value for IR1 1.59 milliampere. The simulation value for IR2 1.41 milliampere, and calculation value for IR2 1.47 milliampere. Simulation value for RC 300 ohm, and calculation value for RC 300 ohm. And another resistor is RE. The simulation value for RE 19 ohm, and calculation value 19 ohm. Simulation value for R1 uh, 8119 ohm, and calculation value for R1 1.8.90 19k ohm. and simulation value for R2 2007 ohm, and calculation value for R2 2007 ohm. Simulation value for VC 7.0 volt, and calculation value for VC 7.5 volt. Simulation value for VE 2.11 volt, and calculation value for VE to 2.25 volt, and simulation value for VR1 uh, 12 12.2 volt, and calculation value for VR1 13.02 volt. And the last simulation value for VR2 2.84 volt, and calculation value for VR2 2.95 volt. Astagfirullah.
In conclusion, transistor biasing is essential for establishing the operating point in electronic circuits, facilitating linear signal application. Through diverse biasing circuits like fixed, collector feedback, emitter and voltage divider, stability and optimal performance are achieved. Proper biasing ensures transistors operate efficiently, meeting the specific requirement of diverse application.